If I have a Van de Graaff generator here, right, or anything that's going to give me a large, massive charge, right? So let's make it a bunch of positives. There is a voltage that is put out, an electrical potential, right? Things that are brought near it have potential to do something, right? And whenever you're really close to it, you have a high potential. Let's say 45 volts right there. And as you go farther out, it drops 30 volts. If I want to take a charge here, let's make it 3.1 coulombs positive, and I want to move it to the 45 volt part, how much work do I have to do? How much work do I have to do? Well, work equals negative Q delta V. That's work equals negative 3.1 times V final minus V initial, which is what? 15. Does everyone see that? V final minus V initial, 15. Meaning I do how much work? What's 3 times 15? 46.5. 46.5. What are the units for work, please? Joules. Good. Joules. Let me talk about why that negative is there. The negative is there because it's from the perspective of the charge itself. You are the one doing work to the charge, right? Meaning the charge is absorbing work. It's having work done to it. Thus it's negative. You're doing positive work. The charge then would be doing negative work at that point in time. If you're doing positive work, thus the charge would be doing negative work. Let's reverse this. Good question. What's the change in voltage here? Well, it's final. This is 45 minus 30. There, that was a big. I can see the little dot down there. Yeah, see what you're saying. Okay. Now let me reverse this. Let's take the same 3.1. Let's make it a proton. I have a proton here, and I'm going to release it, and I'm going to allow this proton to move over here to the 30 volt line. Positive, positive, they want to repel each other, the proton's going to run away, right? How fast is that proton going to go at that point in time, whenever it's all the way out to 30 volt line? Well, work equals negative Q delta V. Work and energy are the same thing, right? So work is the same thing as change in kinetic energy. We okay with that idea? Work and kinetic energy. Tomatoes, You do work, it changes kinetic energy. So now, this is 1/2 m velocity final squared minus 1/2 m velocity initial squared equals negative Q delta V. Whenever you're doing this, by the way, I recommend making sure that the voltage is capitalized and the velocity is lowercase, so you don't get those two mixed up. Right? That happens more often than you think. What's the initial velocity? 0 here. Good. I'm releasing it. So the initial velocity is 0. Leaving me this. 1/2 mass of the proton, final velocity squared equals negative Q delta V. And I know everything but velocity now. No system equation, flow chart. So mass of proton, you get that off the passage. Read that off to me, please. It's 1.6 something.
1.67 negative 0.7.
Give me some more details. 1.60 what?
1.67.
1.67.
3.
We'll go with that. 1.67 times 27. Let me just get you the setup here. Okay? Let me just get you the setup here and give you your back. I'm out of time. Try this homework, please. Page 522. Page 522, numbers 1, 3, 4, 11. Page 522, numbers 1, 3, 4, 11. Some of those are going to use this idea right here that I was doing. 520.